Hey everyone, Grzegorz Baron here. In this video, I want to share some research I did about PBR bakers in my photogrammetry workflow. Basically, I picked 4 different bakers and processed the same set of data with each to compare overall usability, functionality, performance, options they offer, but also what's the most important, the quality of generated texture sets. Knowing what each of them offers allows me to consciously choose the one that best suits my job. Especially that I believe that there is no the best or the only one tool to do the job, and each one has its own pros and cons, but what's the most important, each is in constant change. In details, I presented full baking workflow with the Substance Designer in version 1.1.3, Xnormal in version 3.19.3, Node in 1.2.1, and Marmoset Toolbag 3 in its 3.08 release. Bear in mind that each of these isn't just the baker, but offers some additional functionality which can be very useful in texture creation. As baking strongly depends on the hardware used, you should know that for this test I used a PC with 64 bits Windows 10 installed, with the i7 processor running on 4.2 GHz cores, equipped with the 64 GB of RAM. As a graphics card, I used NVIDIA GeForce GTX 1080 Titanium with the additional 11 GB of DDR5 RAM. As a subject for this comparison, I picked a quite tricky, complex from the height point of view surface and turned it into a 3D model using photogrammetry technique. It was a coastal beach surface covered with different rocks of different type and size. Since I wanted to cover just 180 by 180 cm area for the texture, I marked the area with rulers and captured it, taking 338 images. Next, I processed them with the photo editing software to remove shadows and make sure that colors are physically correct. Finally, I processed these images in Agisoft Metashape and generated a 37 million poly heavy 3D mesh. This mesh is going to be used as our high poly model to present basic functionality and workflow for each baker. Since the mesh wasn't too dense, I decided to carry albedo information using additional texture, and I generated a 16K large albedo map. As a backup, I also stored color information in vertices. Next, I exported the high poly mesh as an FBX file and the texture as 16 bits TIFF bitmap. With the ZBrush, I created a low poly model that can be used to transfer high poly information into the set of textures. I used reconstructed rulers as a scale reference to estimate the low poly model coverage and aligned it to match the scanned terrain level beneath the rocks. Just to give a rough explanation to those who aren't sure about the baking process. The baking is the process to transfer 3-dimensional information, usually carried by the high poly model, into set of 2D PBR textures. To do it, we need to create a low poly model, which is a baking canvas to be used for the data projection. This low poly model should align with the high poly model in 3D space. Everything what's above this plane will be considered as a convex and everything below as a concave. This is why we should position the low poly plane the way it follows the main surface shape, but doesn't follow at the same time any medium or micro height details. This way we are going to avoid cross-surface gradient when one side of the texture is completely at a different height than the other. Next, we need to define the projection range. Some bakers calculate it totally automatically, some handle everything within a given range by itself, but for some the projection distance has to be set fully manually. Basically anything outside of this range won't be taken into consideration during the high poly projection. If the projection distance is too short, the baker can clip everything what wasn't included in the projection area. If the distance is too wide though, we can include random things or parts of different models in a scene which were not part of the reconstruction, or in some cases lose reconstruction accuracy exclusive by not filling the full available dynamic range. So at this stage we should have 3 key things needed to proceed with the actual baking. A high poly mesh, which is going to be used as a source of all high data, a low poly model, which is going to be used as a canvas for high poly data projection, and 60K large 16-bit TIFF texture used to carry albedo information. With these 3 files we can proceed to the baking stage. Let's pick the Substance Designer as the first baker to play with. As I mentioned, the Substance Designer isn't just a baker, but entire advanced node-based system to play with PBR materials. We can get it as a part of entire Substance package for $220 per year in annual subscription, but unfortunately when the year is over we need to pay it again or we lose access to the tool. There's also another way. If we purchase Substance Designer on Steam, currently for £120, I guess it's about $150, so this way we can get a perpetual license with the all software updates until the end of the year of its purchase, and keep using the last available for us version forever if we decide that we don't want to extend the payment for another year. It means that we can use this baker as long as we want, even without paying for it when the year is over. To get access to the baker, let's open a new scene and bring low poly model. And activate the baker window. Next, let's set up the baker. First, we need to select the high poly source model to bake from. Next, let's set the texture's resolution to 4K. Let's save it as 16 bits PNG. Let's set the anti-aliasing super sampling to 4x4. Add textures we want to be baked to the baker render list. Let's keep the baker parameters for ambient occlusion as default. Let's keep the normal orientation as a DirectX. It can be changed to OpenGL later if needed, simply by inverting the green normal map channel. Next, let's add the source for albedo information. We can bring color from vertices using color map from mesh option, but to be totally independent to the mesh density, let's pick transferred texture from mesh instead. This way we can select our texture used to carry color information to be used as an albedo source for baking. Next, let's set the output path and the output texture name. Let's set the distance range which is going to be considered for baking. 0.1 means that the distance is 10% of the overall low poly model size. So by setting it to 0.1, we cover 10% up and 10% down for the projection range, which should be totally enough for this one. If for some reason we need to get a longer distance, we can set this value even higher by typing it manually. Let's keep everything else as it is and start the baking process. Let's speed the video up a bit as this part of the process takes some time. At this stage, the baker has to load our high poly model and start baking textures. It took Substance 2 minutes to load this high poly mesh, 15 minutes to bake the ambient occlusion map, 40 seconds to generate the height map, 15 seconds to get a normal map, and 40 seconds to bake the albedo map. The process can be faster if we have an RTX card or when we just activate the GPU acceleration in preferences, but this way we limit the mesh size we can process as it has to fit the video memory. Anyway, if we skip setting part, it took 17 minutes to process the data by Substance Designer Baker and return 4 high quality 16-bit 4K PBR textures, which is a pretty decent score. With the GPU acceleration turned on, it would take just 6 minutes. Now let's do the same with the XNormal. XNormal is a standalone baker which can be downloaded by anyone totally for free. It's pretty old, as was developed in 2005 when people were using Pentium 4 machines, and was one of the first apps to even use multi-core support. It runs in its own unique and fancy window, and as you will see, still can do pretty decent job. Same as before, we need to select the high poly source we are going to bake from. Add the texture we use to carry color information to the high poly tab. Next, we need to select a low poly model to be used as our baking canvas. In Baking Options tab, we have to select the output path, texture resolution, anti-aliasing, renderer, and set of PBR textures we want to bake. I have found that XNormal somehow doesn't export 16 bits PNGs and exports them as 8 bits, so if you want to store data in 16 bits, I would suggest to select a different format like TIFF. Since we want normal to be baked in DirectX orientation, let's set -y for y coordinates, add a height map, base texture to bake albedo, and finally the ambient occlusion map. Since it takes really a lot of time to bake ambient occlusion map with the XNormal, we can consider to bake it separately using CUDA renderer, as the current version of XNormal supports CUDA rendering for the normal and the ambient occlusion map. But since somehow the CUDA rendering doesn't work for me, let's stick to the current setting. The next thing we need to do is to define the projection range. XNormal has a tool called Ray Distance Calculator, which handles that for us. We just need to bring its window from the Tools section and turn it on by hitting the Go button. Next, XNormal has to load meshes into the memory and calculate projection distance to cover entire high poly model. The actual calculation starts when it starts counting seconds. It is usually worth to wait about 20 to 25 seconds when it starts and just stop it when the numbers marking distance stop changing. But with more complex meshes like this one, it is worth to wait even longer. This way we can be sure we won't get any data clumping like this one in here. But even if we get this, we can still adjust the distances manually. After we stop the calculation, we need to apply the results to the low poly mesh setting by hitting Copy Results button, and we can close the window. Now, when we run the baker, it's going to use these values. If we are not happy with these distances, we can just jump to the low definition meshes section and change them manually to whatever works for us. So let's hit the Generate Maps button to start the baking process. First, the baker loads meshes and the texture, what usually takes some time, and when done, starts actual baking process. It took about a minute. It took 2 minutes to generate a normal map, 2 minutes to calculate a height map. When calculated, XNormal opens a separate tone mapper window where we need to set the minimum and maximum range for the height, so we don't get any height clipping. Let's increase them both to the maximum values and close the tone mapper window and let XNormal to complete the height generation. The next map to be baked is an ambient occlusion map. In theory, we can use CUDA renderer to speed up ambient occlusion and normal map baking, but it doesn't work for me. As far as I know, a new version of XNormal is going to get fully functional CUDA renderer for all maps, which is going to speed up any baking significantly, but since to do this the baker needs to be totally rewritten, I guess it might take really long time to happen. So in this case, it took full 2 hours to generate the ambient occlusion map in 4K resolution. The last texture to be generated is the albedo map. This one took another 3 minutes to be calculated, and the baking is done. Within 2 hours and 10 minutes of processing time, we have another high quality PBR texture set ready for comparison. Now let's move to another baking software and repeat the entire process. This time let's proceed with the Knald. Knald isn't just a baker, but also an image to PBR system, with the baker being a part of it. By paying $100 for the standard freelance license, we get the perpetual license with future updates. So there is no any time limit to use the software, which is a really good thing. Let's turn it on and proceed with the standard procedure. To start baking, we need to bring the baker. When added, it appears in here. Next, we need to bring our high poly source model and a low poly one to be used as a baking canvas. Next, let's bring maps we wanna bake, a height map, a normal map. Let's flip the Y in normal map so it works in DirectX setup, an ambient occlusion map, and finally the albedo map. Unfortunately, Knald in version 1.2.1 doesn't offer the last option, and we are not able to bake from the texture used to carry color information. As you remember during the reconstruction, I also filled vertices with color, and since the only option we have in here is to use vertex color information, let's apply this one. Bear in mind that the option to transfer color from a texture is going to be added with the next Knald update. and we can load and pre-process the bake. It took 1 minute to load the mesh and pre-process the preview bake. When the mesh is loaded, Knald won't need to load it anymore for baking. When done, we can see a 3D preview of the low poly model with temporary baked PBR textures applied. As you can see, the pre-processed result doesn't look great. The reason for this is too short initial projection distance, with the part of the high poly model totally out of the projection range. Let's turn the cage and distance preview on, and turn the high poly preview so we can set the distance the way entire high poly model is covered. Now let's adjust the projection range with the push slider. We can change the opacity to make sure everything is within a range and nothing pops out. Let's set the anti-aliasing to 16 and texture resolution to 4K. Let's increase the amount of rays for the ambient occlusion map to 1000. The value between 1000 and 2000 should be fine for the production quality. Next, let's proceed with the actual bake by hitting the bake button and wait until it's done. It took 5 minutes to bake all 4 textures and additional 2.5 more to calculate the final textures. When calculated, they appear at the top bar. Now they are ready to be exported. Let's set the texture format to PNG. Keep the color depth as 16 bits. Let's set the name and path. And hit the export button. This way we should have all 4 textures stored in Knald folder ready for comparison. To summarize, when we add 1.5 minutes of the initial high poly mesh loading time, which has happened at the pre-processing stage, it took 9 minutes in total to process entire baking with the Knald, which is really awesome. Now let's jump to another baker and proceed with all baking steps. The last baker we are going to play with is the Marmoset Toolbag 3. Marmoset is an amazing 3D real-time rendering system which contains a fully functional and competitive PBR texture baker. We need to pay $189 for a freelance version, which when purchased allows us to keep using the software forever. So far all updates for Toolbag within the same version were free, but we had to pay an upgrade fee for an upgrade from version 2 to 3, so I expect that the same might happen after the Toolbag 4 is released. Anyway, it's definitely a great tool to have, even just to present our PBR stuff. Before we start baking, we need to bring our high poly and the low poly models to the Marmoset Toolbag. Same as in Knald, Marmoset Toolbag fully uses the model we load at this stage, so we don't spend any time to reload it when the actual baking starts. It took almost 2 minutes to load our 37 million heavy high poly model and 1.5 to load the texture used to carry albedo. When loaded, we can see both in real time in a viewport. The materials applied to both can be accessed from the material tab to the right. Since the texture name is the same as the high poly model name, it was loaded and applied to the high poly's albedo channel by default. In case it is not, we would need to add it to the high poly model's material albedo clip manually. Next, let's bring a new baker and drag and drop our high poly and low poly model to the correct position in a bake group. The unique thing about the Marmoset Toolbag compared to other bakers is that even at this stage we still have full control over the high poly and low poly position, so we can still readjust and correct their position in 3D space before the baking happens. We need to get to the low poly setting to set the projection distance which covers the high poly model. To make it more visible, let's change the cage opacity and set the offset the way we are sure entire high poly mesh is covered. This window appeared since we had AutoBake active and it was trying to AutoBake textures, so let's turn it off. When done, let's copy the offset value, as this is our eyeballed maximum distance for the projection, and let's move to the baker setting. Let's set the output path and the bake name. To get higher production quality, let's set samples to 16 and 16 bits to color depth, Let's pick all the maps we want to bake, set the texture's resolution to 4K, let's invert the white channel for the normal map so it can be used in DirectX mode, and let's set proper distance for the height map. This one is quite tricky, it defines the top and the bottom distance for the dynamic range cover. Since we want our low poly plane to be considered as a ground level and everything brighter to be considered as convex while darker as concaves, it has to be represented by 0.5 in float or 128 in RGB. To make it happen, the inner and outer distance values have to be exactly the same, so we need to mirror them. If they are too short, we might get the data clamped, while if too narrow, we won't utilize full available dynamic range. So this is the place where we should paste the value we eyeballed when playing with the cage before. So let's paste it in here, just make sure that the inner distance value got the minus. Next, let's set ambient occlusion to get the higher production quality, and I think we are ready to hit the bake button. The button can be found on the top when the Baker1 group is selected. The big downside of the Toolbag 3 is that the height map's inner and outer range has to be eyeballed, and there is no any automated solution which calculates the distance for us and fills entire dynamic range for us with rendered data if we decide that we don't want to do this manually. Hopefully it's something that is going to be added in a new Marmoset release soon. It's also a shame that we lack of visual feedback during the baking process and cannot easily preview progress for each map during the baking. I had to open Explorer to see them. It took 40 seconds to render and save the normal map, 10 seconds to get the height map, 7 minutes to bake the ambient occlusion map, and 10 seconds to get the color map. So basically it took 8 minutes to bake all 4 maps in 16 bits and 4K resolution. If we add 3.5 minutes for initial mesh and texture load, we can say that full processing time with the Toolbag 3 took about 12 minutes. Anyway, when done, we can turn off the high poly model and use full power of the real-time rendering system to preview our result in PBR environment. So now we have all bakers covered and we can compare them. First, let's compare the results. Since the video is recorded in 1080, I will present cropped version from the 4K to present exact 1:1 pixel size from the bake. Let's split the image into 4 parts, where each represents different baker, and assign baker's name so we can see which one is which. Next, let's have a closer look on the height map. Personally, I like results delivered by the X-Normal and Knald the most. These bakers manage to fill entire dynamic range, so in case when we convert them into 8 bits, they store more high information within the same dynamic range. Substance Designer and Toolbag are also totally fine, but their dynamic range wasn't fully utilized. A good way to test the height map quality is to use it as a displacement map. So let's jump into the ZBrush, bring a plane, subdivide it so it's dense enough to drive height information, set the stroke type to drag rect, load our 4 height maps and use each as a stamp to check out the surface response. The one generated with the substance works totally fine and brings all the details to the mesh. Also, the one generated with Knald works great. The one rendered by X-Normal works also fine. The one rendered by Toolbag seems to be too flat and lacks of response. We can change the intensity and it is still fine, since 16-bit stores enough data to still have all the information, but if we would turn the map into 8 bits, we would get very noticeable bending, something like this one. Each baker did great job with the normal map. I can't see any relevant difference between bakers. Regarding the ambient occlusion map, all did great job too. Don't know what do you think, but I would probably prefer the one rendered with Knald and the Substance Designer, but I would be really happy with any of these bakes as all are very high quality. Next, let's take a closer look on the albedo map comparison. The one baked with the Knald is totally blurred and lacks of surface information compared to others. It's a definite loser in here. Other bakes look exactly the same. Again, I would say that I would be super happy with any of these, except one baked with the Knald. Looking on results, all bakers did really decent job, and it's really hard to say which one is better. Of course, except the obvious poor quality for the albedo map baked by the Knald, as color information wasn't carried by the texture by the vertex color. Fortunately, with the next update, Knald gets the missing option to transfer color information using a texture too, and since I had an opportunity to test it in beta already, I can say it works great. It means that when it is released, there will be no way to see any difference compared to other bakers between the baking quality for Albedo. Now let's pick everything together and try to point pros and cons of each baker and see where it shines and where it doesn't. So let's compare all factors which might be relevant in baking comparison. I believe these are things like overall user interface and its usability, types of output maps we can bake, supported mesh file formats, output file formats, mesh size limits, baking speed, baking quality, price, and additional functionality. The first one I mention is a factor which affects entire setting part and feedback we get from the software. This definitely affects the setup time and overall user experience of baking preparation. In my opinion, XNormal has overcomplicated user interface and doesn't provide too much feedback during the baker setting. We usually don't know if we miss something until it's too late. The XNormal interface probably looks the most cool and the most unique when compared with other bakers' UI, but we really need to know already what we are doing if we want to use it. I can imagine that it can be a painful tool to work with when we deal with really complex baking setups. Marmoset Toolbag 3 also doesn't feel very user-friendly, especially when someone starts with it. Even if it feels way better when compared to XNormal, I still believe there is a field for a few UI improvements. It lacks a context help when we hover mouse over options, which in my opinion would be very useful, especially for new users. What I like about the Toolbag is that it gives real-time option to adjust the high poly and the low poly model alignment in a scene and gives real-time feedback regarding the cage distance setting. This can be really handy when we deal with complex objects. Unfortunately, the Marmoset Toolbag 3 doesn't have any tool which offers in-progress baking feedback for the final bake. While it is very hard to find out how to open the Substance Designer Baker window, especially if we don't know how to do it, when we finally do, we get a very simple, functional and well-organized user interface. In my opinion, Substance Designer Baker is quite easy to set thanks to the setting window, which gives decent overview of all our options. It lacks the visual feedback for the high poly and low poly model alignment, but offers in-progress window, which is very handy as we can see if something goes wrong and stop the baker. I really like this one, but the way to open it really could be done better. With the Knald we get a very well and wise design interface. It offers very high quality and very useful feedback regarding the baking setting. The Knald's UI also offers real-time context help, which appears when we hover the mouse over options. This way everyone can easily check what each setting does and what value and why should we set. It has a very useful pre-bake 3D preview window, but unfortunately lacks the real in-progress baking window. We still get the feedback about the progress, but only in a text form. I would say that each of these has its own strong and weak points, and there is no a definite loser or the winner in this category. The next factor we should take into consideration are output map types, which are basically the types of PBR textures we can set to be rendered by the baker. Each software delivers full range of PBR options. Substance Designer offers 17 basic output types, Knald offers 13 key output types, but with the incoming update it gets even more. We'll add them to the list as it's just a matter of the next update to get them. XNormal offers 17 key baking options, while the Marmoset Toolbag 3 offers 29 of them. So I would say that each baker offers full PBR baking functionality, maybe except the Knald, which in the current version lacks of the texture transfer for the Albedo. I would say that Toolbag is the winner here, since it's always better to have more options than find out that something is missing when we really need it. The next factor is the supported mesh file formats we can use. This one is quite important as gives us more options to work with. Basically, these are 3D mesh file formats we can load for baking. baking. If the format we use to carry high poly data isn't supported by the baker, the software won't be able to load and open it, and if that's the case, the baker is basically useless for us. Substance Designer Baker seems to support only 5 file formats, which isn't much. Knald supports just 3, which is even worse. XNormal is super versatile and supports 18 of them, which is crazy and turns it into the most versatile option. Marmoset Toolbag 3 supports 9, which is also great. I would say that the XNormal total rules in here. Toolbag 3 is fantastic. Substance Designer isn't bad, but it lacks the PLY format, which is one of the key formats to carry very heavy high poly data. It means that Knald, which supports just 3 formats, by having PLY included, might be still a better solution to Substance for some. The next thing to compare are the texture output formats we can use to export baking results. Substance Designer offers 12 options, Knald offers 5, XNormal offers 10, while Marmoset Toolbag 3 just 4. The Substance Designer definitely wins in here. XNormal also is great, Knald offers just 5, but really strong ones. I would say it would be perfect if it has a PSD, but it doesn't. Marmoset Toolbag 3 offers just 4, and I really believe that it would benefit a lot if it would get additionally at least TIFF and EXR. The next factor to consider is how each baker deals with very heavy geometry. This is a very important one, especially for those who work on very heavy meshes and strongly depends on available RAM memory. After my research, I can say that each of these bakers deals with meshes up to 100 million polys without any big problems, but the higher we go, the more issues we get. Basically, in theory, 10 million polys needs 1 GB of RAM memory. So, for example, to process 100 million polys, we need 10 GB of free RAM. XNormal utilizes a CPU renderer and is limited just by the available standard RAM memory. It means that there are no other limits really, and we can process really heavy meshes here. Even 1 billion poly if we have 128 GB of RAM. Toolbag is a full GPU renderer and needs to fit all the data into the video memory. So basically anything above 100 million polys on a GPU with 11 GB of video memory like GeForce 1080 is not going to happen. Keep in mind that the texture used to transfer color information also takes some video memory. Substance Designer utilizes both a GPU and a CPU. How the baking is being processed depends on the actual hardware and the setting in preferences. If we use NVIDIA, it uses DXR backend on Windows, Optix on Linux. If it doesn't support RTX, it falls back to Optix. For AMD GPUs, it also falls back to CPU, as the current generation doesn't support DXR. It is worth to mention that for all non-from-mesh formats, the baking in Designer Baker is purely done on CPU. Knald also seems to utilize both a CPU and a GPU. My guess is that it cleans the mesh before it is added into the video memory for preprocessing, but actual baking calculations happens on CPU. This is why I guess it can handle much heavier meshes to Toolbag when compared, even with less video memory. So basically the mesh size we can process by baker is limited by the available RAM memory. For GPU bakers by video memory, for CPU bakers by standard RAM. Some bakers mixes both approaches to be more versatile and increase the baking speed. XNormal is a definite winner in here. I would give the second place to both, to the Knald and to the Substance Designer. As far as I know, with the new Knald's update, Knald should offer support for over 400 million plus trees heavy meshes. Substance Designer seems to be slightly behind, but the software seems to be more versatile regarding the hardware we have. Marmoset Toolbag unfortunately can handle very heavy meshes, since even the most fancy graphics card available to purchase offers very limited amount of RAM. I can tell that during my research with the GeForce 1080 and 11 GB of video memory, I had some real issues trying to bake 150 million polydense mesh with that Marmoset Toolbag 3, while at the same time every other baker dealt with the same geometry without any problems. Now let's take a look on baking times. It took 17 minutes to load the mesh and bake all 4 maps with the Substance Designer, 9 minutes with Knald, 2 hours and 10 minutes with the XNormal, and 12 minutes with the Marmoset Toolbag 3. But if we would turn the GPU acceleration for Substance Designer Baker on, the baking time would change to just 6 minutes. I would say that overall baking speed was totally acceptable, and all bakers except the XNormal did a really great job in here. The XNormal also did great until it totally failed with the ambient occlusion map bake. The CUDA support, which in theory should speed up the baking process for the ambient occlusion, somehow didn't work for me. But no matter how quick the baking process was or what the file format we can export, if the quality of the bake is poor, the baking is useless for us. So the overall baking quality is, in my opinion, the key and the most important factor in this comparison. I don't mind waiting even 1 more hour if it is justified by the quality I get. I don't care if bake took 1 second if it's crap. Fortunately, each baker from this comparison delivered roughly the same very high quality results. The Knald was a small exception, as the current version lacks the option to bake from the texture, but since it's just a matter of a single update, I would say it's fine. Of course, since it isn't there yet, I would say that in current state it is a big no and wouldn't use Knald Baker without it, but after it is added, I might consider Knald as one of the best bakers on the market. The last but not least is the software affordability. Currently, we need to pay about $220 to get Substance Designer in a Substance package as an indie user in annual subscription. If we don't extend the subscription when the year is over, we lose access to the software. But there is still an option to buy just a Substance Designer as a standalone app on Steam for about $150 and keep it forever with all updates limited to the year of purchase. Knald would cost us $100 per perpetual indie license. Marmoset Toolbag Free costs us $189, while the XNormal is just totally free for everyone. So this is what we need to pay to get access to each baker, and XNormal wins here by being totally free. Substance Designer is definitely the most expensive solution in long term if we get trapped into subscription model, but if we manage to get it on Steam, it isn't as bad anymore. Knald seems to be a great and very reliable solution if we bake a lot and don't need anything more. Marmoset Toolbag is probably the most expensive solution if we plan to use it just as a baker, but the price is really tricky to compare as each software offers additional functionality which can be also really very useful for us. If we consider it, the price comparison makes a bit more sense. So Substance Designer Baker is the part of the entire advanced node-based system we can use to work on PBR materials. With the Knald Baker, we also get quite interesting image to PBR system, which allows us to generate PBR textures based on photographs. XNormal also offers a few interesting converters, but they are not anything special nowadays. Marmoset Toolbag, however, offers an amazing, fully functional, easy to use and high quality real-time 3D rendering system, where the Baker seems to be just a small part of it. So it is really up to us to decide if the additional functionality is somewhat useful for us or is it totally irrelevant. So what is the final verdict? Sorry, but honestly I don't have any. I would just repeat what I have said at the beginning of this video. There is no the best or the only one tool to do the job, and each one has its own pros and cons and is in constant change. Only when we know them all, we can have the opportunity to make a conscious choice and choose the one that suits us the best. I really hope you found this video useful. If you like it and want me to share even more content like this one, please leave the thumbs up, drop a comment and subscribe to my channel. Big thanks to all of you who did it already. Take care, stay safe, and hopefully till the next one. Bye!